So this is Patches, and he loves to do calculus. He's a math cat. So he'll probably be in the videos a lot because he loves to do math with me. Okay, so now on this one, when I see those three terms and that there's different powers, I think I might be able to factor it. So I'm going to give it a shot, and lots of times it works to just split that first one. So I'm going to do sine squared, because I know if I multiply those back, I will get sine to the fourth. And then I look at this last term and I go, oh, it looks like it's got to end with a cosine squared and a cosine squared. Because if I multiply those back, I'll get a cosine to the fourth. It's positive, so they either both need to be positive or both negative, but this is positive. And so then if I just double check the middle term, I would have a sine squared cosine squared and another sine squared cosine squared, which will give me 2. So hey, it works. And so then I notice, oh my goodness, look, I see Mrs. Torres, what a creeper she is, because sine squared plus cosine squared is 1, and so 1 times 1 equals, ta-da! Even Patches knew the answer to that. It's 1. Okay, so one thing to remember when you're finding all the solutions is it needs to be set equal to 0 in the event that you're factoring. This one currently is, but I want to solve for cosine x, so I'm going to add this over and then divide by 2. So I'll have cosine x equals square root of 3 over 2, and then I have to think, ooh, when's cosine equal to the square root of 3 over 2? So of course, really what I'm doing is I'm cosine inversing both sides. Of course, I usually think that through in my head. When's cosine equals square root of 3 over 2, and of course that would happen at pi over 6, and again at 11 pi over 6. Whoops. And since it says find all solutions, I could spin around the circle and be back at those same spots if I do 2 pi k, plus or minus 2 pi k. Next one. So this one, I need to set it equal to 0 first. It's illegal to start dividing by sine of theta because there's a possibility that sine of theta is actually equal to 0, and so I'd go to jail for dividing by 0. But I can totally subtract it over, and then I notice, oh my gosh, there's 2 terms. I might be able to do the F word. Factor, silly, what were you thinking? So I'm going to factor out a sine of theta, and then I have 2 separate factors, just like when I'm factoring quadratics, so I will set them both equal to 0 and finish solving. Oh, there goes Patches. He got a little bored. This was too easy for him. He said it was review. And so I'm going to sine inverse both sides. And so then I'll find out that theta equals, so let's see, when is sine equal to 0? Oh, it's equal to 0 at 0. Or again at pi, or again at 2 pi. And so this one's going to actually repeat every pi. That only happens in that one special instance where sine happens to be 0. That's the only time for sine. Otherwise, it's the tangent function that does that. And then over here, of course, getting sine theta. Oh, I forgot to put it in the theta. I forget that a lot. So if I get sine theta by itself, I will have sine theta equals 1/2. And again, I want to inverse both sides to get rid of the sine. Don't you dare say divide by sine, it will make me scream, and then I'll wake your parents up because you're probably doing this really late. And so I'll find out that theta is 1/2, or rather that sine of theta is 1/2 at pi over 6, and again at 5 pi over 6, and of course, since I'm doing all solutions, I can do plus or minus 2 pi k because I could spin around the circle until I barf and land on that same spot. Next problem. So now here's what I notice on this one is that they're trying to confuse me by mixing trig values with sine and cosine. So I just have to decide, could I substitute one for the other? Well, I can if there's a squared because I have my favorite trig identity, which is sine squared plus cosine squared equals Mrs. Torres because she's number 1. And so I could substitute for sine squared a 1 minus cosine squared. And time's going to run out, so I will have to see you in the next video.